Here is our section for today. So we're doing section 3.1. It's all about relationships between lines, and your objective is to identify relationships between lines. You will have a notebook quiz on this chapter, so make sure, again, like always, you get the number, you get the title, and you get your objective every single day. Alright, first vocabulary word of the day is parallel lines. I do want you to write the definition. And then under the definition, I just want you to write this. That is a symbol that indicates that two lines are parallel. So, we've already talked about parallel lines. You should already know this definition, but I do think it is helpful to have it in your notes again. Parallel lines are two lines that lie on the same plane and do not intersect. So, two key things. They have to be on the same plane and they do not intersect. So we've talked about these previously, like the white lines on the outside of a roadway. Those are parallel lines. They'll go on and on forever next to each other. They will never cross. The sides of a railroad track, those are parallel lines. Many, many examples you could think of for parallel lines. The sides of a sidewalk, those are parallel lines. Another way to show that lines are parallel without using the word parallel is to put these like thick arrows on top of the line. So if you see that in a diagram, that is telling you that those two lines are parallel. So again, you don't need to write all of this, just the definition and then the symbol that's in that little rectangle. Any questions on parallel lines? Alright, here's your next definition. These are perpendicular lines. I don't think we've ever actually defined these in your notes, so this is definitely a good one to write down. Just like last time, just the definition and then the symbol will be just fine. Perpendicular lines are lines that intersect to form right angles. So the way you can show that two lines are perpendicular, it's like an upside down capital T, basically two little perpendicular lines. So definitely get that symbol down next to the definition. And then the way you show this in a diagram, you're very familiar with this, the little box. So if you see the little box, that is telling you that that's a 90-degree angle, it's a right angle, and that those two lines are perpendicular. So let's look at part A. Line T and line U, and remember when there's a lowercase letter next to the line, that's not a point on the line, that's the actual entire line that they're naming. So T is here and then U is here. Are those parallel, perpendicular, or neither? So parallel is where they never intersect but they're on the same plane. Perpendicular, is where they intersect at a right angle, and then if it's neither, then it's neither. So T and U. U is here, T is here. So is this a right angle right here? No. So they can't be perpendicular, but they do touch, so they can't be parallel, so what does it have to be? Neither. Very good. S, T, what about those? Those are parallel. Good. If you want to show parallel without writing the word parallel, you can do the two parallel lines. And then R and U. Yep, R is here, U is here. You can see this little box indicates that they are perpendicular. Perpendicular is an upside down T. What are your questions? So, skew lines are lines that do not lie on the same plane and do not intersect. The tricky thing with skew lines is when you put it on a 2D piece of paper, like the picture of the tissue box on the board, it looks like they're going to intersect right here, right? You need to imagine it as an actual 3D object. If you were looking at the back upside down corner, like going up and down corner, and then the top corner right next to you on a tissue box, and you extended them on forever, like let's say you put rulers on and see if they intersect, they would not, okay? So you can't think of it as a 2D flat figure. You have to actually imagine it as a 3D object. You're holding it in your hand, okay? So again, those are called skew lines. So they don't intersect, but they are not on the same plane. Any questions on skew lines? So determine whether the lines are skew. So we are just going to say yes, they are skew, or no, they are not skew. So A and B, are those skew or not skew? Not skew. Why are they not skew? Because they touch. If they intersect, they are not skew. What about B and C? Skew or not skew? Not skew. Why are those not skew? They're on the same plane. So again, A and B touch, so they're not skew. B and C are on the same plane, so they're not skew. You can probably guess how the next one's going to turn out. A and C are skew. Yes, very good. Because they do not intersect. Again, it looks like they do if you imagine this to be flat, but you have to picture it as a plane with like a line shooting through the plane. So it would not be able to touch the plane here and here. Alright, so this is not an actual point of intersection when you imagine it as a 3D figure. So again, they don't touch and they're not on the same plane, so A and C are skew. What are your questions? All right, you do not need to write this one down. I think it's pretty commonsensical. Parallel planes are two planes that don't intersect. So if you imagine the floor and the ceiling of this room, those would be parallel planes. They're planes that go on forever, flat surfaces planes, and they don't touch each other. There's no such thing as a skew plane, because remember, they're going on and on forever, so eventually they would touch. So they're either totally parallel or they will intersect. All right, and those are planes, very similar to parallel lines, parallel planes. Another thing I like to think of is like Oreo cookies, like the two cookies, those are parallel planes. All right, they don't intersect, they just kind of hover right above each other. And again, you do not need to write this down. Any questions? This one I do want you to write down because this is kind of a new concept. This is a line that is perpendicular to a plane. So a line perpendicular to a plane is a line that intersects a plane at a point, and that is perpendicular to every line on the plane it intersects. So a nice way to think of this is like a flagpole. That flagpole will form a 90-degree angle with every line that it intersects on the ground. All right, so that is a line that is parallel to a plane. You don't need to write down the bottom part or draw a flagpole or anything, just the definition will be good. This is what a line that's perpendicular to a plane will look like. So the red line is the line that's perpendicular to the blue plane, and the reason it's perpendicular to the plane is because it's perpendicular to all the lines on the plane that would intersect it. So you can see all of those are right angles. So this line is perpendicular to that entire plane. Any questions? Alright, here is example 3. I am going to say that you do not need to draw this because it's kind of complicated. So just go ahead and write A, B, C, and then we'll answer it in a way that kind of tells you what the problem was asking anyway. So you don't need to write out the problems and you don't need to draw this, but make sure you're getting the right answers down. And then let's just talk about the diagram for a second. Whenever you have a capital letter in the corner of a plane, that represents the whole plane. So there's no point R. The whole plane is R. This whole plane is P. This whole plane is Q. This is line M. M is not a point on the line. This is line L. And over here we have line N. Any questions before we look at the actual examples? A says, name a plane that appears parallel to plane P. It's a tongue twister. So here's plane P. Which plane is parallel to plane P? Which one does not intersect P? Which plane? There's only 3 planes. Yes, good. So, P is parallel to Q is how I'm going to write that. So again, if you don't want to write out the question, if you write your answer in a way that sort of indicates what the question was, you can get away with it. So P is parallel to Q. Good. Name a line that is perpendicular to plane R. So R is the white plane. Which line meets R at a right angle? There's only one place where I see a right angle. Here. So that's line M. Good. So I'm going to write M perpendicular to R. Name a line that is skewed to M. So we're back with this line M. Which line is skewed to M? P is the plane, so it can't be P. We're talking about line M. Which one is skew with M? R is a plane. The only lines are M, L, and N. The rest are planes. L and M intersect right there, so they cannot be skew. R is not a line. What? N, yes, that was tricky. Yes, see how M is going up and down and R is going like behind M side to side? Those are not on the same plane and they will not intersect, so they are skew. I do not have a fancy symbol for skew, so just put N. That will work. What are your questions? All right, last set of examples. You do not need to attempt to draw this. You do not need to write out all the problems. We'll try to answer the problems in a way that shows you what the original question was. So let's jump right in. This diagram looks like you kind of have a ramp with, they're naming the planes with 3 letters now. Remember, 3 letters defines 3 points to find a plane, so that's legit. So we are first trying to find a plane that appears to be parallel to plane ABC. So ABC is this gray one. Which plane is parallel to ABC? E, F, D. Very good. So I'm going to write the symbol for parallel, and I'm going to say E, F, D. So if you write that whole thing, you can get out of writing the problem, because again, we're indicating what the problem was in our answer. That the EDB or EFD should be written on one line. I just didn't want to cover up our B. Number 10, name a line that is perpendicular to plane A, B, D. So now we're not talking about the gray plane, we're talking about like the back side of this ramp. So like the tall side of the ramp is the one we're looking at, and we're trying to find a line that is perpendicular to that plane. E what? EA is not. EA lies on the plane. EF would work. Yes, those appear to be perpendicular. So does line AC. Remember, when you're talking about lines, you need 2 letters, unless it's like a lowercase letter next to the line naming the whole line. These are points on the line, so we need 2 of them. So I'll go with the one I heard first. And we're talking about perpendicular, so EF. F, and then we're talking about the line, so put arrows on the end, and there you have it. 11. Name a line that is perpendicular to plane AEC. So now we're talking about the floor, AEC. So which line? F is on the plane. DE will work, or AB would work. Good. I'll just go with the first one I heard, which was DE. Now, to be honest, if this was mine, I would probably stick with the one that's labeled as being perpendicular. There isn't really a right angle symbol over here, but I mean, we can basically assume since we're discussing it as a class. But normally, I'd stick with the one that's labeled as being perpendicular in the diagram, just to be on the safe side. But on this one, we're good. I'm just gonna cheat. Let's just say there's a little box there. All right. 12. Name a line that is skew to BC. BC is like this line coming up here. DF is actually parallel. So DF is the answer for the next one, which one's parallel to BC. But we're looking for ones that are not on the same plane and also won't intersect. So those are on the same plane, so they're parallel. ED will work, yep. Yeah, because if you're looking at a ramp, like BC is the part going up at the slant, and then ED is like shooting straight up from the back of the ramp. So yeah, those are definitely skew. Any questions? Again, the hard part is taking the 2D representation, the flat picture, and thinking of it as an actual object for these. That's the difficult part. Questions? All right, your homework today is worksheet 3.1, practice B. So I'm going to pass those out. Those are due tomorrow at the beginning of class.